Record. Okay, so introduction to networking. What you should have an idea of by the end of this lesson is you should have an idea that there's many different devices that are used in computing networking, and also this concept of protocols, the OSI stack, that type of thing. So you probably, people are telling me that they did 1106, so this is not new. Sorry for that. But yeah, hopefully you can see this. So what we want to look at is also the client server versus the peer-to-peer network. And I'm sorry about the way that this is oriented. I'll try and come up with a better way next time, I guess. Identify types of applications and protocols. So when we talk about applications that are used over networks. So on our network, we're using, for example, our browser applications, but we use lots of other applications. I'm not going to go through them now because there's a slide that relates to those. Then we're going to look at some of the hardware that's involved in network computing. So the OSI model, 7-layer model, you may remember it. If you did 1106, you remember that. And so that features strongly in this course as well. Troubleshooting. Actually, at the end of this lecture, there's a bunch of stuff about safety. So we'll see how that goes. Hopefully you can see this. So maybe these terms are familiar to you as well. Topology, physical topology, and logical topology. So physical topology is how the components work together. So is logical topology, but just talking about it from the physical versus the logical, right? So what's our physical? Where hardware describes how computers, other devices are connected together, whereas logical has to do with the software and the devices and that type of thing. So how users and programs initially gain access. I'm looking up there because I can see it better without my glasses. Whereas if I look at my laptop, I have to use my glasses. I'll just do that. Network operating system, that's important because a minute ago, I mentioned that we'll talk about the difference between client service and peer-to-peer networks. If you're going to have a client service network, you're going to need a network operating system on the server. And you're going to need a server. So the other option is peer-to-peer. We'll talk about that in a minute. Am I going too fast? Am I going fast enough? I could go faster.
It's all good, sir.
All right. So a very simple network is a peer-to-peer network that's built into Microsoft Windows. That's pushed out onto, well, sorry, not pushed out, but which is delivered on your laptop computer. You can connect a couple of cables to somebody else, and you can start a little network sharing. You can even do it over Wi-Fi. So you don't need to have any extra devices or software for that, for a peer-to-peer network. Peer-to-peer networks work pretty good as long as the number of devices in the network is pretty small. So you can have a Windows local account and you can use that to connect a group to make a peer-to-peer network. So this diagram is supposed to show an example of a peer-to-peer network, and you notice a sort of a mesh architecture. You might have heard that word before, but that is where every device can be connected to every other device, you know, through the network. And notice these networks, they don't even share the same operating system. So as long as those operating systems provide for some level of connectivity, then we're going to use our network standards to make those connections. So we got Ubuntu, which is a Linux sort of variant, Windows, which is of course Windows, and Mac, all connected in this network. Quite possible. So why would we use a peer-to-peer network? Use it at home. It doesn't cost much money. But the problem is when it's not scalable. What we mean by scalable is when you start adding larger numbers of devices. Peer-to-peer network is because all the traffic is going to everybody. You know, every time you send a message, it goes to everybody. You got no way of identifying any particular device on that. So what happens is that everybody's communication is carrying all of that load, and it's very inefficient, and it might not be secure, as it says. So the preferred way of running a network is, especially if it's a larger network, if we want to scale it up, is to use a client-server model. So the client-server model, as it suggests, you have a server, which is serving the network with whatever services are required to be served out. So you can have, so there's many different types of servers, as you'd be aware, right? So you have web servers, you have print servers, etc. So you have a server which has the resource that needs to be shared. And then you have some kind of network operating system, which is working with that. So NOS is our abbreviation for network operating system. We talk about this idea of a Windows domain. So a domain is going to be a group of devices which are in a particular part of that network. Active Directory is used by the network operating system, in this case, Windows. In this case, Windows Server 2016 or whatever. They're going to have an Active Directory, which is going to keep a record of all the devices that are connected to the network. So in other words, the server is kind of controlling the communication on the network. It has a directory of what devices are on the network, what devices can be allowed on the network. And so it's keeping that process. So that's managed by this thing called ADDS, Active Directory Domain Services. So the idea of a client, the client is going to receive the service. So we connect to a network with our laptops, for example, and then the server is going to provide a service to us. And that is more efficient because that server is a single point, which so we don't have, for example, for a printer. So you could have one printer which was shared by many people. And so the service is being provided through a print server, and we connect to the print server through our network. And then the print server provides us with that service, which printed out stuff afterwards. So we're not, the resources or the services are with the server rather than with the client's directory. Where if you went to the peer-to-peer network, you could have a printer on your laptop and you could share that with somebody else in your little peer-to-peer, but that's your printer, right? You could also stop sharing it, right? Whereas it's not something that's shared sort of with everybody else. So client-server model, could say that it's ideally suited for a star-type physical topology. So you can see that there we have a server and lots of devices connected to the server. And then the server has a resource which is associated with the server. In this case, we got a domain database which is controlling the access of all of these other things. And so I mean, but any of these things could be shared through the server. But typically, so what do we got there? Yeah. So that's a domain, one domain which is centered on a server, so that all of these devices are in that domain. What about the network operating system? What does it also do? I can manage data and resources. Sorry, I'm just reading this. It's a lot of words there, right? So yeah, I hope that just, I don't want to just read slides. I don't like that. Just to sum that up, the server is actually providing the control. That's all I'm going to sort of say for that, right? So the access and security, that's going to be sort of controlled through the server itself, rather than the individual sort of clients. Individual clients will have to have some kind of application to access the things on the server, but then the server is going to sort of control access to it. So that's it. So these, I hope this is obvious. If you have a server which is going to be providing the same service to multiple clients, it's going to need more resources, right? So you're going to have a more powerful processor, or at least as powerful a processor as is practical, and you're going to usually have large data storage on your server. And yeah, there may be some other special hardware that's associated with that. So there's the thing, it's going to be a little bit more secure because we got credentials that are going to be used and they're going to be managed centrally on the server. And yeah, more scalable, meaning that it's easier to add new clients without it badly affecting the service to others. All right, so yeah. These are some examples, I guess, of client-server applications. So network services, as it says there. Oh, is that what we're talking about? We're talking about protocols. Sorry, I can't really see that. mentioned here are a few protocols, TCP IP, which is required for any network that we're using in the modern networks. So the protocols, I think what this slide is trying to say, and it's not very clear, but what it's trying to say is that the server is going to manage these things and sort of, as it says, provide that central point. So it's going to be managing those protocols for the security, etc. Are you familiar with these terms TCP and IP? You'll find those in the 7-layer protocol stack as well. So we'll talk about that. Those are the protocols that it's referring to there. Okay, so a web browser on the laptop here, connecting through the internet to a web server. So in this case, a web server is very remote. This is not an individual LAN, local area network. So when we connect to the internet, where the internet is that network, the huge global network of networks, right? And so when we connect to that, we need to connect to a server. The web server is going to provide the whatever's on that web that we're using. So it could be a shopping site, it could be D2L, it could be Zoom, right? So there's a server there that is providing that service for us, connecting through the internet. That's still a client service application. Now, this is a list of applications that, as it says, run in a client server way. So web service, which we talked about, email. We've got, now with each of these, there are typically special applications and protocols that special protocols that work for that application. We'll talk about that with email in particular, because you kind of do need to know about those. FTP, your file transport, that's very important in, it's built into your web browser actually, because when you go onto the web, you can click onto a PDF and it comes to you directly. So that's a file transfer protocol that's coming there. But we also have more secure file transport protocols. If you guys have done any web development, you probably use something like FileZilla. So basically, it's with something like FileZilla, it's just taking the file transport protocol and sort of adding some features to it to make it more reliable and easier to use. So, and then Telnet, this is a service which allows you to remotely take control of another device. So that sounds like a good thing, but usually on our web servers we actually block that. But you know, if you're running an IT service like the guys downstairs, they're going to be using that kind of protocol so that they can sort of control you. Remote applications and remote desktop, similar thing. I do need to put my glasses back on. Sorry about that. All right, so yes, I mentioned that if you're using email, there's a couple of protocols that are specifically for email. And so, for example, when you send an email to a web server, now notice that there's 2 web servers there, right? So there's there's 2 email servers there, 2 mail servers. So one is the local mail server where you're sending the mail to, and you're going to use the SMTP protocol to upload your email to your server. And then that's going to be routed using that same protocol to the destination. Then it's going to sit on the destination, and that's where it sits until the receiver well, what do we do? You know, we go and we read our email, right? We open up our email app, and then at that point, then another protocol, which is going to be POP3 or IMAP4, is going to then download that. If it's POP3, it's going to download onto the receiver's device, and there it'll sit. Or if it's IMAP4, then the user will just read it on the server, and it will remain on the server. So there's a few, I'm sorry, this is kind of hard to read that, right? But I'm sorry, this is kind of small, but what you might be able to see there is it looks like a Windows Explorer type window, but what's kind of hard to see in the corner there is that we're actually able to look at and explore files that are on multiple devices. So we got files that are on a remote computer that are showing up in a sort of like a file manager type sort of situation. So once you've got your network connected and you've done your sharing and stuff like that, you can share files sort of directly, just using the inbuilt software of your operating system, because you've done this with, this is because of a server. You need a server. All right, so some of the hardware that you're going to come across. I mentioned a minute ago the local area network versus the internet, right? So your local area network is usually defined to a small geographical spot. So like here in the college, we have a local area network. As it says, an office or a building. Then we have some other devices that are necessary for that. Switches. You need a lot of switches in a computer network like we've got here at the college. And all the switch is going to do is going to connect to lots of devices that are on the network, and it can connect to other switches, and it can connect to routers. We have this idea of a star topology. The star topology just means that, well, I should say it's sort of not just implied, but it's kind of forced upon us physically by the architecture of a switch, because the switch is going to have an input, and it's going to have all of these ports. It's got many ports, and so it is just naturally by design a star. However, the internal connections in the switch allow it to be configured in other ways, right? So it can be configured to be like a bus, just by using the software that's loaded onto the switch. You can connect different ports on the switch directly. Then we have this idea of a network interface card. Your network interface card is built into every device which connects to a network. So with my laptop, my network interface card has two components to it. It has a radio, and that allows me to do the Wi-Fi, but it also has an Ethernet port so that I can connect to my Ethernet using my NIC. Now, the NIC, very importantly, also has a unique MAC, right, which is your MAC address, which allows you to identify that hardware uniquely in the universe, I guess you could say. So every device has a MAC address which is unique. So it's a physical address, as opposed to when we start talking about IP addresses. Those are logical addresses which are assigned by the network and can be changed. Right. So our network interface card is going to provide us with a physical address. All right, so each of these devices, as I said, would have a network interface card. And quite likely, the way that this network is designed, is built there, it looks like they're all connecting using Ethernet cable to a switch. Yeah. And if you look at this switch, we've got two different switches there in that diagram. The one at the bottom is said to be a switch that could be a consumer grade, so something that you might put in your house, I guess. Whereas the one at the top is an industry grade, and you notice there's a lot more ports. So your industry grade is also going to have, as I said, going to be programmable. Typically now your switches, we talk about, so you remember the OSI model at all from last year? I don't know, but we talk about layer 2, layer 3. All right, so layer 3 is where we do our IP addressing. Layer 2 is just our frames and our MAC addresses, that type of thing. So a switch is working at layer 2, a pure switch. But nowadays, the hardware is quite well developed so that we have layer 3 switches that can sort of actually kind of work almost like a router. So what do we got there? That's an NIC, network interface card. So for the old computers, where they have slots to add components to them, one of the components that you might add would be a network interface card with an Ethernet port, RJ45. But nowadays, that's usually built in, right? It's usually built in, and we're using a lot more of smaller devices. They still have NIC, but it's built in. It's very small, and it doesn't connect to an RJ45. It might connect to a USB 3. Or it might connect to a radio. It's going to connect to a radio. So, as it says there, LAN means local area network. Switches are just devices to connect many devices together. They are nowadays quite more advanced and complicated than they used to be. So there's a lot of very clever and efficient computing that we can do with switches to make that networking more efficient. Yeah, a switch, you can have many switches connected together in a single network, as long as you don't have a router, because routers are used to connect multiple networks together. So router is going to have more than one IP address. But as long as you don't have a router, you're going to be all on the same network. So you can daisy change your switches together, and you can have a bus. You can have a star bus. So you can have a bunch of switches that are connected together in a daisy chain. And each of those switches has a star coming out from them. And that's what this is here. This is our star bus topology. How's this going? Too fast, too slow? I'm not hearing anything from folks. I hope it's all right. I am recording, so you can go back and have a look at that afterwards. So when we really get I'm going to say from my point of view, the switch is really the power of a small network. But if you want to sort of connect to the rest of the world, you're going to need a router. And so the router is our real power. That's definitely the power behind the internet, is our routers. And if we have a large network of our own, it's the power behind that, because a router allows you to connect to another network. And a router can connect to multiple networks, not just two, 2, 3, whatever. You need a different port and an IP address for each one. So that depends on how the router has been organized. So routers can be used in small networks, can be used to connect a small network to the internet. You'd need a router for that. Industrial grade routers, as it said, can be used for much larger networks. Here at the college, we'd have several routers as well. And as it says, it's like a gateway between networks. Very nice to sort of, yeah. Here we have, right? So here's your home office, I guess you could say, right? Maybe you've got a router and then you've got a switch behind it connected to the internet. More likely, you've got a single device that acts as a router and a switch. I mean, that's what Arito is installing in people's computer and people's homes nowadays. So you got this thing sitting on the wall, and yeah, it is connected to your fiber cable, right? Coming in, and then it has maybe it even has a radio on it, but more likely it's got a Ethernet cable to another device that is going to work for a radio inside your home to give you Wi-Fi. And all right, so the thing that you should pick up from this, do you see we've got 3 switches, but each of those switches is servicing a separate network. So we've got networks A, B, and C, and they're all connected by the router. So the router is able to route traffic between the networks. So somebody in network C wants to send a message to a network A. What will happen is the network protocols will put an address on the message so that it goes to, it's not sent to network B, it only gets sent to network A. That's kind of good. MANs and WANs, I don't know if you're familiar with those at all. MAN, Metropolitan Area Network, WANs, Wide Area Network. So Metropolitan Area Network, typically in like a university or a college where you have multiple campuses, but you want them all to sort of work together. You could use a MAN, but they're all in the sort of same geographical area, but it might be kind of broad. And you might use some kind of your own, so you own the communication links. So you might have some kind of microwave between 2 different campuses in the same city. That could work as a MAN. A WAN, on the other hand, typically when we use the term WAN, what we mean is we're going to be using a third party to provide us with our link between two distant networks that are going to be joined together by a third party network. So if we're going to Arito and we're connecting to them somehow through our router to somebody that's in like another country or in Dukan or something like that, then we'd be using a WAN. And a PAN, personal area network. You have, oh look, I've got this device here and it connects to my phone. I mean, so it's not much of a big leap from this. This is recording my heartbeat as I go. It records where I've been. So that's not a very expensive device. It's consumer grade, and it goes to my mobile phone. My mobile phone's connected to the internet. I could be connected to it by an app to my doctor, who would be saying, okay, your heart rate's good, or he could be saying, well, your blood pressure is this. So you could have all kinds of monitoring devices on you that could then communicate to your mobile phone, and then from your mobile phone, you got the whole world that you can communicate to. You could be talking to a doctor in Switzerland or something like that. Who could be telling you, about your. So that's my best understanding of how a PAN might work, and maybe you can think of some others. Okay, so did I miss something? PAN, there it is. Yeah. Okay, so MANs and WANs. See the link between these two routers. The WAN, that represents, probably like Rito, right? Except the American version of Rito. I don't know what it would be. So they would go and they would contact some telephone company and say, we want a link between San Francisco and Philadelphia, and then they would sort of set that up for you using their telephone network. And however they would do it, there would be different. They would probably give you a number of options. Okay, we can give you a direct cable or something like that. That's going to cost you a lot of money, or else we're going to let you just sort of do it. We'll charge you by the bit rate that goes through there, and we'll just let you sort of go with the rest of the traffic, which is probably what you're going to choose. Or we'll send you off some satellite or something like that. They'll give you different options with different prices when you go to them, but they'll provide that link. And the good thing about that, from the point of view of you building this network, this is network, you own all this stuff with all the switches and all the rest of it, but right up to the router. But the good thing is that all the stuff in the WAN, you don't have to worry about that. The company, you pay them a monthly fee, and they do that for you. The telephone company does that for you. You don't have to. That technology is not your concern. Now the 7-layer model, this diagram, sorry, it doesn't show the several layers very clearly. I apologize for that, but no, I don't want to do that. But what it does show is that here we got a point where we're sending. So here we got a point where we're sending, that relates to this. We send a message, right? And well, this is like, the analogy is you're sending a letter. You wrote a letter, you took it to the post box. They drove it across the country. They went on the highways. Then they got to the other post box and they give it to the receiver. So you write an email, all right, you put it on the server, and then, the server connected to the WAN. So your WAN is analogous to this highway. And then there's another server where it arrives, and then, the person takes it off. Now, the OSI model, the idea is, do you notice that you start at the top and you go down through the layers, and then you get to a particular layer, which is linking the two things together, and then you go back up this model. That's how the OSI works. Okay, so we are communicating at this level together, but in order to do that, we had to go down through these other layers and back up. So that's our OSI model. So there's 7 layers in the OSI model, and this diagram, I'm just very sorry about this, so I'm not going to spend a lot of time on that because this one's better. So here's our 7 layers. When you want to send an email, you're using an application, which is at the 7th layer. And at the 7th layer, you're going to be using for an email, you're going to be connecting using a browser probably for your email. So HTTP is going to be involved, probably HTTPS, because you've got encrypted email. And then you've got SMTP that's going to load your email message onto the server. And FTP is for, no, we're using SMTP for the email. FMTP if we had some PDFs or something like that we wanted to include. So that's our application layer. Now notice application layer, presentation layer, session layer, they're kind of together. They're together because when you send a message, we're doing this thing called encapsulation. We take the message and we put onto it particular addressing information, if you like, that makes it possible for that to go to the right place. And so in terms of that, in terms of our encapsulation, these kind of work kind of the same. So at the end of it, when we've used these protocols, what we end up with is this thing called a segment, okay, or a PDU, depending on which transport protocol we're using. Do you remember the transport protocols, which are TCP and UDP? So depending on which one of those you're using, if you're using TCP, then you got a segment. If you're using UDP, then you got a PDU. But at that point, what you've got is you've got your data in the middle of this segment, and the segment's got some sort of information about addressing for that. So there's your TCP and your UDP. Then it goes to the network layer. The network layer is below that. The network layer requires an IP address, and so the IP address will be added to the segment, and then you have a thing called a packet. And a packet can go out onto a network. Packets are going to be switched by routers. Routers deal with packets. Well, actually, they'll take in a frame, and then they'll strip off the physical addressing, and then they have the IP address, which they'll get a new IP address depending on where you want to send it to. Then the data link layer, that's going to be getting down to our physical addressing, and lastly, our physical layer, that's where we just send it out on the wire. And so we go down the protocol stack to get our email message out on the wire. It's out on the wire, then it comes to the place, the destination, right? And the destination is going to look at this thing called the frame, and it's going to sort of, well, it's going to go through many routers on the way, I suppose. And every time it goes through a router, it's going to take the frame, it's going to strip off the frame bit, look at the IP address, and re-encapsulate it with another frame, and then send it out to into the right router there. Eventually, it's going to be at the place where it's going to be delivered, and then the frame will be stripped off. Then we have the IP address to send it to the right server, and then from there, it's going to from there it's going to be processed and eventually read by the user. Using the at the very end, the user is going to use their POP or their IMAP to read that email. All right, so it says here I've got 4 minutes and left. So what I can see people yawning, and I've been talking for a long time. So what I propose to do, it's 9:04. What I propose to do is to stop. I'm going to stop now. I'm going to save this, and I'm going to start again because we got a 3-hour lecture. I mean, I'm sorry they did this. I don't want to blame anybody else for it. I'm sorry that this is the way it is. But we've got 3 hours of lecture, and I can't just sort of leave it at 40 minutes. I think we need to finish this lecture today. So what I propose to do, you see we're on slide 32. The next part of the lecture won't be nearly as long, all right, because the end is all this safety stuff. We just sort of cruise through that. But what I propose to do is to stop for 10 minutes. You guys go and take a walk. Does that sound okay? And I will open up the meeting again at 9:15. Okay, so at 9:15 we will start again. So I'm going to close the meeting now. I'll send you. Do I need to send a reminder to people because the people are asleep on the other end, or are they still there? I don't know. But at what I see is 18 participants. I'm just going to send that message. Same link. Yes, same link. 9:15. Start again. So people at home, it's easy for you because you've been sitting there sort of drinking your coffee and walking around anyways. But the people here, they've been sitting here and they sort of felt like they couldn't sleep. So, all right. See you at 9:15.
See you, sir.
Yeah. Right. So I'm going to stop recording.